Alright, so this is section 1.4, and we're going to discuss rational expressions. So we want to be able to simplify rational expressions. We'll do that through different processes of multiplication, division, addition, and subtraction. And we'll talk about complex fractions and kind of what those mean. So first we have some examples of rational expressions. Rational expressions are just similar to a rational number. They're expressions that can be represented by a fraction. So that being, two polynomials in the form of a fraction. So 8 divided by x minus 1, 3x squared plus 4x divided by 5x minus 6. So these are just examples of millions of rational expressions. Alright, so this is an example of simplifying a rational expression, and this is where greatest common factor comes back in. So it may take you some practice to realize this, but just to kind of quickly go through this. So the greatest common factor of both of these are 6. So I can rewrite both of these as 2 times 6m, and then negative 3 times 6. Alright, and so as we know through what, people do not like to say cancel, but 6 divided by 6 is just 1. So I can cross those out, and that leaves me with 2m over 3, and that's negative. Okay, so that would be 12m divided by negative 18 in its simplest form. Again, it will take some practice to recognize the greatest common factor, but if you can find the greatest common factor, then you can just break it apart into something times the greatest common factor, and you'll be able to divide out the greatest common factor. And there's a way to do it in Desmos that I'll post a separate video for you to check out. Okay, so here we have multiplication and division. So when we have multiplication between two fractional polynomials or rational expressions, we want to multiply just straight across the numerator, straight across the denominator. But with division, we want to take the reciprocal, flip the fraction. So the reciprocal is just flipping the fraction, and we want to do that to the second fraction, and then we just multiply. So make sure you simplify things as far as you possibly can. So just make sure to keep a check on that. Okay, so here would be an example of multiplication. So again, I want to multiply straight across. So 5 times 2 is 10. And 6 times 3 is 18. And then we have the x. Okay, but I'm not done. So here would be a situation where I want to do, like we did in the first example, where I would find the greatest common factor of these and rewrite it as the greatest common factor times whatever to make it equal 10. So the greatest common factor for 10 and 18 is 2. So I can say 2 times 5, and then 2 times 9x. Now 2 divided by 2 is just 1, so I can cross those out. And that leaves me with 5 divided by 9x. Now, since 5 and 9 do not have any common factors outside of 1, then I can leave it there, and that'd be my final answer. Okay, so with division, as I've already mentioned, but with division we want to flip the second fraction or take the reciprocal of it, and then that turns it to multiplication. So we have 8x over 5 times 20 over 11x squared. Now I can multiply straight across, so I have 160x divided by 55x squared. Now, again, this would be a good time to use Desmos. Check out the video for the greatest common denominator / greatest common factor. But I can break this apart into 5 times 32x and 5 times 11x squared. All right, so now I can say, all right, 5 divided by 5, those reduce to 1, so I can cross those out. That leaves me with 32x over 11x squared. Okay, so now I've taken care of my coefficients of 32 and 11, so I can't simplify those any farther. But I do have an x and an x squared, so in crossing out the same way that I would think about, right, 32x and then an x squared is the same as saying x times x. So now I have x divided by x, so I could get rid of that. And so now I would have 32 over 11x. And so now that is as simple as I could possibly take that given expression. Okay, so now with addition and subtraction, as long as we have a common denominator, then we can just add or subtract the numerators just the way that we always would. Okay, so for the first one, all I have to do, because I have a common denominator of 5k, then I just say 4 plus 11 is 15. And then my denominator stays the same of 5k. Okay, so your denominator will stay the same. Now I can just reduce this, and depending on, if you want to do the greatest common denominator, or the greatest common factor, or you can just say, okay, well, 15 divided by 5 is 3 over k, and that would suffice perfectly. Now for my second one here, I have r plus 2 over 3 divided by r minus 2 over 3. So for this one, I would say, okay, well, I have r plus 2 minus, and remember that it's the entire thing being subtracted. Okay, so r plus 2, I need to make sure that I distribute the negative to both the r and the negative 2. So I actually have r plus 2 minus r plus 2 divided by 3. Now you can see that we have like terms of r, and we have positive and negative r, so those would equal 0. So then my final answer would be 2 plus 2 is 4 divided by 3. Now, we might have some examples and times where we do not have a common denominator given to us, and we need to find one. All right, so one thing to make sure of, our goal is to make both denominators look the same, but whatever we do to the denominator, we also have to do to the numerator. Okay, so first example here that I want to show you is 4 divided by 3 times k plus 1 plus 3 divided by k plus 1. And so my goal again is to make the denominators look the same by either multiplying or dividing by something. Okay, so for this one, I already have a 4 over 3k plus 1. All right, but if I notice here, I have k plus 1 in my second one. So if I just multiply it by 3, then that becomes 3k plus 1. Or 3 times k plus 1. Okay? Now, reminder, whatever I do to the numerator, I also have to do to, or whatever I do to the denominator, I have to also do to the numerator. So since I multiplied the denominator by 3, I also need to multiply the numerator by 3. So 3 times 3 would give me 9. Now I can just do my basic arithmetic and just add across the numerators. So 4 plus 9 is 13, divided by 3 times k plus 1. Here would be a time I would want to check and see if I can reduce this any. 13 and 3 do not have any common factors, so therefore that is simplified as possible. All right, so here would be an example of a subtraction where we have a quadratic in the denominator and they are not the same. So again, we want to try to find a common denominator. So when you have a quadratic like this in the denominator, go ahead and factor it. And if you're unsure about factoring, check out video 1.3 or check out the Khan Academy YouTube video that I have posted on the As You Learn page. But I'm going to go ahead and factor both denominators. So I have 2y divided by y plus 3 and y plus 4 minus y divided by y plus 2 and y plus 3. Okay, so now I notice that these both do have a y plus 3 in common, but I still want to make them look the same. So essentially what I need to do now is for my first term of my 2y divided by y plus 3 times y plus 4, since it's missing a y plus 2, I'll just multiply it by y plus 2. So I have y plus 2, y plus 3, y plus 4. So that will be my new denominator. And then the same would be here, y plus 2, y plus 3, and y plus 4. Okay. All right, so now, again, whatever I did to the denominator, I have to do to the numerator. So for my first term, I had to multiply it by y plus 2, so I want to say 2y times y plus 2. And then for my second term, I had to multiply it by y plus 4 because it didn't have one. So I have to say y times y plus 4. Now I could go ahead and expand those out. So I have 2y squared plus 4y. And just a reminder that since we're adding and subtracting, but we now have a common denominator, I can just put this all over the same denominator. So y plus 2, y plus 3, and y plus 4. And I want to subtract my y times y is y squared. But remember, this negative sign has to distribute to both things. So I also have minus 4y. Now I can just combine like terms. And so I have 2y squared minus y squared, which leaves me with y squared. 4y minus 4y would be 0. So all I'm left with is y squared over y plus 2 times y plus 3 times y plus 4. Again, if you have any questions, please do not hesitate to email me, but have a great rest of your day.